Hello guys, and welcome to lesson 7C or 8C. I can use trigonometric functions and inverse trigonometric functions to find missing values. So this is your first foray really into trigonometry properly as a study of math. And what it is, it's the study of the relationship between sides and angles in a triangle. There are a handful of basic functions that we need to understand in order to be successful on later, and these three functions are sine, cosine, and tangent. And they rely on the relation of the sides to the angles in a right triangle. Now, before we can really talk about that, we need to be sure that we're clear on what sides we're discussing. So you're always going to have an angle of interest, some kind of angle that you're studying. So for example, if I'm looking at angle B, okay, I always look at the sides in relation to angle B. Side Y is adjacent to angle B because it physically touches angle B. Side X is the opposite side of angle B, and side Z is always the hypotenuse because it's across from the right angle. Now notice, Z is adjacent to B, but because it's the hypotenuse, we don't call it the adjacent side. Similarly, if we're looking over here at angle C, we have X is adjacent to angle C, Y is opposite angle C, so X is adjacent, Y is opposite, and Z is still the hypotenuse. So let's talk about our three basic functions, sine, cosine, and tangent. Your sine function is always equal to the opposite side divided by the hypotenuse. So the length of the opposite side divided by the length of the hypotenuse. So if we're looking at angle B, for example, I am going to pull the side opposite angle B, that's X, and the hypotenuse, which is Z. And so my sine of B is equal to X over Z. Sine of C, on the other hand, sine of C would be opposite, which is Y, over Z, which is the hypotenuse. So opposite over hypotenuse. Cosine is always equal to adjacent over hypotenuse. So if I'm looking at cosine of angle B, my adjacent is Y, my hypotenuse is Z, so it'd be Y over Z. And the cosine of angle C, on the other hand, my adjacent side is X, so we would do X, there's a typo here, friends, divided by the hypotenuse, which is always Z. And then tangent is opposite over adjacent. So if I'm looking at angle B again, opposite side is X, adjacent side is Y, so it'd be X over Y. Similarly for tangent of C, my opposite side is Y, and my adjacent side is X, so it'd be Y over X. Now, there is an abbreviation to help us remember this, and it is SOHCAHTOA. SOHCAHTOA stands for sine equals opposite divided by hypotenuse, cosine equals adjacent divided by hypotenuse, tangent equals opposite divided by adjacent. SOHCAHTOA. Guys, if you can remember this phrase, SOHCAHTOA, you can do 90% of the problems that we do in this unit. So this is your big idea. Highlight it, star it, do something that you remember that this is the big idea today, is SOHCAHTOA. So let's do some practice problems. All right, we are going to first identify some sides. My hypotenuse here is FD, and the side opposite angle F is DE. Adjacent to angle F then must be FE because it's not the hypotenuse. This is my hypotenuse. This is my opposite, so the leftover must be my adjacent side, FE. Now let's look at angle D. The side opposite angle D is FE. The side adjacent to angle D is the thing that's not the hypotenuse, because then the hypotenuse doesn't change, so that must be this guy here, DE. So let's talk about these different relationships. Again, we're remembering our big phrase, SOHCAHTOA. So if I want sine is opposite over hypotenuse. So the sine of angle D I've got written in blue, my opposite side is FE. over my hypotenuse, which is always FD. My cosine is always adjacent over hypotenuse. Well, my adjacent side to angle D we determined was DE, and my hypotenuse is always FD. And then the tangent of D is opposite over adjacent. So my opposite side of angle D is FE. And my adjacent side to FD, or to angle D, is DE. Now let's take a look at angle F. My sine is opposite over hypotenuse. So the opposite side of angle F is DE. And again, my hypotenuse doesn't change no matter what my angle is. That would just be FD. Cosine is adjacent over hypotenuse. Well, my adjacent side to angle F is FE. And the hypotenuse is still FD. And then my tangent is opposite over adjacent. That's my OA, right? Soka Toa. Opposite of angle F is F, or opposite of angle F is DE, and adjacent is FE. And those are our relations for that one. Now, we can actually do these with real numbers. So here's a new picture. Again, I'm going to be paying careful attention to what my actual angles are here. So if I'm looking at B, here's my B. Okay, the opposite of B is 40. My hypotenuse is 50, which means that the adjacent side for angle B is 30. So let's do all the ones with angle B first. So sine is opposite over hypotenuse. Opposite over hypotenuse. Well, in this case, that's going to be 40 over 50, which reduces to 4/5. Cosine of angle B is adjacent over hypotenuse. That's my ka, so ka, toa. Well, my adjacent side to angle B is 30. The hypotenuse is 50, so my answer must be 3/5. And then tangent is opposite over adjacent. My opposite side was 40. My adjacent side was 30, so my answer is 4/3. Now, I want you guys now to do the exact same analysis for angle C. Keeping in mind that for angle C, this is my opposite side, this is still the hypotenuse, and this is my adjacent side. So go ahead, guys, and do this for angle C. And go ahead and check your answer. All right, guys, let's think about this. Why do we not calculate the sine of angle A? Well, the sine of angle A, when we look at angle A right now, that's 90 degrees. Do you notice how the hypotenuse of angle A and the opposite side of angle A happen to be the same value? We don't calculate the sine of angle A because it's our right angle, and the opposite and hypotenuse values are essentially the same. What is the same segment, so it doesn't make any sense for us to calculate it. All right, let's keep going on. All right, we can also use a calculator to help us find some trig values. So this, guys, is when you need your big, fancy TI Inspire calculator. You need it every single class from this day forward. You don't want any other calculator but your TI Inspire. This is not a time to bring in a little 4-function calculator. It will not do the trick. So we are now in our calculator just going to make sure we have all the correct settings on our calculator. So I want you guys to take out your calculator, go to the home page, and I want you guys to go right here to 5 settings. And under settings, I want you to go to document settings. And under document settings, you need to make sure that this thing right here that says angle, it needs to be where on degree. You'll learn about radians and pre-cal, but right now we're going to deal with only degrees because that's how you guys know how to measure angles. I want you to click make default so that it's always that way in your calculator. So again, guys, if you don't have this set up correctly, you will get the wrong answer if you don't have it set to the right form of angle. All right, so let's go back to our notes. We're going to calculate the sine of 30 degrees, cosine of 30 degrees, and tangent of 30 degrees in our calculator right now. So right now, I want you guys right here, do you see this button here? It says trig arrow. If you click that button, it gives you lots of choices. And you can then, in theory, ooh, something weird is happening with mine. I'm sorry, guys. In theory, you can then choose different values, different trig values. We're only going to be dealing with sine, cosine, and tangent, so don't worry about the other ones right now. You'll get to them in higher maths for right now. sine, cosine, and tangent. So if I take the sine of 30 degrees, I get 0.5. And if I want to do the cosine of 30 degrees, I get 0.866. And the tangent of, escape please, 30 degrees gets me 0.577. So 0.5, 0.866, and 0.577. So let's fill those in. 0.5, 0.866, 0.577. All right, guys, I want y'all to pause now and find the cosine and sine, cosine, and tangent of 60 degrees and 45 degrees right now in your calculator. Go. All right, so check your answers against mine. I'm rounding to the thousands place. There are some cool patterns in here. If you notice, 30 and 60 add to 90, and when that happens, the sine and cosine functions will be equal for the opposite values. Another cool thing, if you've got a 45-degree angle, that would make this an isosceles right triangle, right? If this is 45 degrees, that would mean that these two sides end up being congruent. Therefore, it makes sense that these two are equal and that the relationship of this side divided by this side is going to be 1. So there are some cool similarities in here. All right, so let's now figure out how to find missing values with this. So we're able now to set up sine, cosine, and tangent equations to help us find missing values in calculators if we know one of the angle measures and one of the side lengths. So your first step whenever you do these, your first step is I want you to label the sides of your triangle. Sides of triangle as opposite, adjacent, or hypotenuse. So again, we look at the angle that we're talking about, this angle right here, which would make this side my opposite. Across from 90 degrees is the hypotenuse, and whatever is left over is my adjacent. Your second step then is to choose a trig value for based on what you have and what you need to find. I have an adjacent side. I want to find an opposite side. So when I'm thinking about SOHCAHTOA, I want to choose one that has an O and an A. Well, the one that has an O and an A for me is the tangent. So I'm then going to write an appropriate trig equation. And solve. So what does that look like? Well, I'm going to say that the tangent of 32 is equal to my opposite, which is x, over my adjacent, which is 13. So to solve this equation, I want to multiply both sides by 13 to cancel the 13 in the denominator there. So I get 13 times the tangent of 32 is equal to x. Well, this would be called the exact form of the equation, but if you want the approximate version, you hop in your calculator, you do 13 times the tangent of 32, and I get 8.123 as my answer. 8.123 equals x. And let's do another example together now. Here we have another triangle. I always start off by identifying the angle I'm interested in and labeling my side. So this side must be opposite. This side is the hypotenuse, which leaves this guy as the adjacent. I look at the thing I have and the side I want. That's an O and H. So when I'm thinking about SOHCAHTOA, I want something with an O and an H. O and an H is here. So I'm going to do sine of the angle I'm interested in equals my opposite is 10.8, my adjacent is x. Now to solve this equation, I want to clear the x out of the denominator first by multiplying on both sides by it. So my x's cancel here. So now I have x times the sine of 57 equals 10.8. I'm going to divide both sides by the sine of 57, so I get x equals 10.8 divided by the sine of 57. And then I put that in my calculator to solve it. So I go to the calculator, I do 10.8 divided by the sine of 57, and I get 12.878 as my answer. All right, let's do another example. I first start off by identify the angle I'm interested in. That's 47. I label my sides. Woo, hello. I label my sides. Why isn't this working? I'm sorry, friends. This guy is opposite. This here would be the hypotenuse. The leftover is my adjacent. So I've got, the thing I have is an h. The thing I'm interested in is an x. So when I'm thinking about SOHCAHTOA, I want something with an a and an h. That's cosine. So cosine of 47, Miss Rob, not what I just wrote, 47 is equal to the adjacent, which is x, over the hypotenuse, which is 3. And now I'm going to solve this. I multiply by whatever's on the denominator to cancel the denominator, to do that. So now I have 3 times the cosine of 47 equals x. Well, that's fully simplified, so I plug it in the calculator. 3 times the cosine of 57 gets me 1.633. 1.633 is equal to x, and that's my missing side length. And guys, this side length makes sense. If 3 is the hypotenuse, it's supposed to be the longest side length in the triangle. So the x value here I should be less than that, and it's less than that by an appropriate amount. So, all right, now let's talk about inverse trig. I know, guys, this is a long video. Bear with me. We're learning a lot, but it'll all make sense here in the end. If we know the side lengths, but not the angle, we need to undo a trigonometric function that we use to find the side length. The functions we need to do this are called inverse trigonometric functions, and the inverse trigonometric function finds missing angles rather than missing sides. So for example, if I know that the sine of g is equal to 0.5163, then I know that the measure of angle g would equal the sine inverse of 0.5163. This right here is called sine inverse. That -1 is very important. So when I hop in my calculator, if you look under your trig function menu again, you'll see right here, we've got a sine inverse function, right? And so I can then put 0.5163 in that function, and it tells me that the angle I would have started with is 31.084 degrees. I guess I said to the nearest tenth, 31.1 degrees. So we're now going to practice finding the angles that produce these particular ratios. So if I have cosine of m equals 0.2894, therefore the measure of angle m will equal the sine inverse, or cosine inverse, the cosine inverse of 0.2894, which equals, hop in the calculator, we go to our trig menu, I want cosine inverse of 0.2894, and I get 73.2 degrees. So coming back here, we get 73.2 degrees. I want you guys now to find the values of 3, 4, and 5 in your calculator. So go ahead and do that now. All right, so check your answers against mine, make sure you understand. All right, let's move on now and talk about how we actually can use these. So just like last time, we have the same initial setup. We identify the angle we're interested in. Oh, by the way, guys, when we have a missing angle, we typically use the Greek letter theta, which looks like an O with a line through the middle of it, for missing angles. It's like using x, but we're using the variable theta. So we identify the angle we're interested in, and we label our sides, as we were before. Opposite, hypotenuse, leftover must be adjacent. And we take now the two things we're given, O and an H, and we're thinking again about SOHCAHTOA. Notice this is the big idea in this whole lesson, right? SOHCAHTOA. So if I want O and H, that's a sine function. So I would say sine of theta equals O over H is 12 over 24. Or, now since I'm looking for an angle, I do theta equals sine inverse of 12 over 24. And then we jump into the calculator now to find that out. I would go where is it? Trig sine inverse of 12 over 24, and I get 30 degrees, which means that theta equals 30 degrees. Now, something kind of cool here about this is if you notice 12 over 24 is reducible. If I had done the sine inverse of 1/2, I still get 30 degrees. So if you reduce that fraction, you get the same answer. Let's keep going though. So my next one, we're gonna do right here, number 8. I identify my angle of interest first and I label the sides. Opposite, this guy must be the hypotenuse. So this left over here must be my adjacent. And look at what I have. H and A, that's AH. That's gonna be, we're dealing with cosine territory. Well, cosine of theta equals adjacent over hypotenuse, that's 6 over 9. Therefore, theta equals the cosine inverse of 6 over 9, which is, so I'm going to do right here, the trig cosine inverse of 6 over 9, which gets me 48.2. So my answer is 48.2 degrees. Let's do, I want you guys now to do number 8 on your own. Do number 8 on your own. All right, guys, go ahead and check your answer. You should get 73.7 degrees. Now, let's look at this last one together. This last one, you have all of your sides. So when I identify the angle of interest, I label my sides. Opposite, hypotenuse, left over must be adjacent. Guys, because I've got all 3 sides, I can choose which function I want to use. I could do the sine of theta equals opposite is 42 and a hypotenuse is 70, or I could do the sine or the cosine marker, thank you, or I could do the cosine of theta equals adjacent is 56 over 70, or I could even do the tangent of theta equals opposite is 42 cosine or adjacent is 56. And here's the cool thing. When I do these 3 in the calculator, which I'm going to do right now, when I do the inverse functions of these 3 in the calculator with the correct numbers plugged in, notice I get the same answer every time, so it doesn't matter which one I choose, I'll always produce 36.9 degrees as my answer. So you have choices sometimes. All right, so let's talk about how do you determine when to do what? So, problems involving right triangles. If you're given one angle and one side, and you need to find a side, you're going to use regular trig, not the inverse. Regular trig. Whereas if you're given 2 sides and you need to find an angle, you're going to use inverse trig. That's the -1, right? Inverse trig. So I just want you guys to be aware that if you need to figure out whether or not you're using inverse function, think about what you're given versus what you're looking for and whether or not you use regular inverse trig. So on this problem here, I'm given an angle and a side, right? This guy is going to be a regular old trig. Whereas on this one here, I'm given 2 sides and an angle. This is going to be inverse trig. So work those out real quick, guys, and we'll check our answers right now. So in this first one, when I mark my sides, I find that I have an opposite side. I'm looking for an adjacent side, so I'm going to use a tangent function. And it's tangent of the angle, which in this case is 25, equals opposite over adjacent, 7 over x. And now we're going to solve. And when I walk through solving this, I multiply both sides by x, then divide by tangent of 25. I get 15.012 for my side length. Now let's take a look at this next one. I start off by labeling my side lengths. Then I determine I've got an a and an h, so I'm using cosine. That's cosine of x equals 31 over 64. Because I'm hunting for the angle, I'm going to use inverse trig. And when I plug it into the calculator, the cosine inverse of 31 over 64, I get 61.0 degrees. All right, guys, it's the end of our video. I'm sorry it was long. You've got 2 practice assignments because this really is a 2-day lesson. So y'all have a great day, and thank you very much.